this lesson, you will solve and graph absolute value inequalities with less than, which is always an intersection. And you'll also solve and graph absolute value inequalities with a greater than, which is always a union. And if you'll remember from the last lesson, intersections graph is always a line segment, and unions graph is always one ray or two rays. So the graphs are going to match the symbol that you see. And we'll be talking about that more in a moment. So first of all, what is absolute value? If you remember, it's distance from zero. So just one real quick example here. Absolute value of -3 is how far is -3 from 0? So that would be 3. But if you'll also remember, the absolute value of 3 is also 3 steps from 0. So we can have two different possibilities of what can be inside. We have a positive case and we have a negative case. And the same thing works. There are 3 different types of symbols. We can have an equals, a less than, or a greater than. And so what is the answer to what number could be inside the absolute value that is 5 steps from 0? Well, we would have 2 cases, right? -5 is 5 steps from 0, and 5 is also 5 steps from 0. So you're always going to solve 2 cases, a positive case and a negative case on all of these. So let's look at an example of that. Let's suppose that whatever's inside is less than 5. So that distance has to be less than 5 units. If you would look here, this is -5. It has to be less than 5 steps this way and less than 5 steps this way. So do you see how this less than symbol creates an intersection, which is a line segment? So all of our graphs are going to be that same way. So here's our less than symbol. We know we're going to have a line segment. We know that. But we do have to solve for the variable. So I'm going to make a positive case. The negative case, we're going to do 2 things. We're going to make the symbol flip because it's a negative, and then we're going to make the value on the right side negative. So this will be m plus 2 is greater than, we flip the symbol, and then we make it -11. That's the negative case. So on this positive case, we're going to subtract 2, and we get m is less than 9. On the negative case, we subtract 2, and we get m is greater than -13. So let's just graph it first. Here is -13. Here is positive 9. If you'll look, it is less than 9, so it does not include the 9. Greater than the -13 does not include it, and it's a line segment between. So we would write m such that, what's this number here? We start there, -13, and we have m in between, number here, 9. And then I just have to put in the symbols to match. So this is less than, and here the alligator is eating the m, so it's less than. This is the best way to write an intersection, especially when it's a line segment graph. Do you see how this matches? Here. This is the way we'd want to write it. So I'll give you one to try in your notes. Here is a real-world problem. A recent survey showed that 65% of young adults watched online videos. The margin of error was within 3 percentage points. So we want to find the range of young adults who use video sharing sites. So if you remember the last time we did an absolute value problem together, if we have x be the number of adults, we know that we have absolute value x minus 65 because it's a positive 65%. And in this margin of error, we want to be going through intersections, so that's less than. We're going to say equal to as well because it's within 3 percentage points. So if it's 3 away, it still counts. And then 3 is your absolute value. If you were thinking of a graph, a line segment, this would be a line segment because the symbol matches. And I'll do some practice with practice of this with you tomorrow if you're not understanding the real-world application of it. Now, what about a greater than symbol? Well, I already told you it's going to be a union, so you know what the graph will look like. But let's say this distance has to be greater than 5. So more than 5 steps away would be going this direction. More than 5 steps away would be going this direction. So do you see how it's a union? It's going to be less than -5 or greater than 5. But we still have to solve 2 cases. So we start with the positive case, and we're going to go now to the negative case. Do you remember what we do? Two things. We're going to flip the symbol, and we're going to make it negative. We do those two things every time we do a two case. So let's go to the positive. We subtract 6. 3n is greater than or equal to 6. Divide by 3, and we get n is greater than or equal to 2. Now we know that this should be either 2 rays or 1 ray because it's a greater than symbol. And we'll look at the graph and see what happens. Subtract 6. We have 3n is less than or equal to negative 18. Divide by 3, n is less than or equal to negative 6. So we have negative 6 here. We have 2 here. It is less than or equal to negative 6, so I include that, and it's less than it. It is greater than or equal to 2, so I include that, and it's greater than. So you can see clearly it's 2 rays. We write n such that we start here, n is less than or equal to negative 6, or n greater than or equal to 2. This is the best way to write a union. This is what the graph of the union would look like. So try the example in your notes.